Okay, so here's our next one, talking about proving angles congruent using 4 different methods: side, 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 angle, angle, and side, or angle, angle, side. So here's our warm-up. We need to refer to the figure and find x. So we know that the 2 triangles are congruent. Gives us that. It also gives us that the sides that are with x are congruent. So the 6x plus 5 is congruent to 9x minus 4. We just set those equal to each other. So 9x minus 4 is equal to 6x plus 5. We subtract 6x from both sides. Got 3x left over, minus 4, equal to 5. Now we're going to add 4 to both sides. 5 plus 4 is 9, so we have 3x equal to 9. Then we divide by 3 on both sides, and we'll get what x is. 9 divided by 3 is just 3, so x is equal to 3. For number 2, we need to find y, because measure of angle A is 12y plus 3, and we want to know what it actually is. So angle A and angle D match up. They are congruent. So we just set those equal to each other. 12y plus 3 equal to 9y plus 18. Same process, just different numbers. Subtract 9y from both sides. 12y minus 9y is 3y plus 3 equal to 18. And we subtract 3 from both sides. 18 minus 3 is 15, so 3y is equal to 15. And we divide by 3 again on both sides. Y comes out to be 15 divided by 3 is 5. Now, this didn't want us to find y, it wanted us to find what the measure of angle A is. But we needed y to do that. So the measure of angle A is equal to 12y plus 3. We plug our 5 we got for y in, so 12 times 5 plus 3. 12 times 5 is 60. We add 3 to that, and the measure of angle A is 63 degrees. So our vocab words for today just included angle and included side. Side, side, side congruence. If 3 sides of one triangle are congruent to 3 sides of a second triangle, then the triangles are congruent. So here we need to prove that these 2 triangles are congruent. And to do that, we're going to have to use the distance formula. So let me write that at the top, just so I have space. The distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. So that's our distance formula. We've used it before. You remember back to the notes over that. So now, with this problem, we're going to have to use that distance formula 6 times. We're going to find 3 sides for one triangle, and if the other 3 sides for the other triangle match up, then we have 2 congruent triangles. So we're going to start with side DV. And our x's are -5 and -1. And it doesn't really matter which one you choose to be which. I just like to go in order. And our y values are -1 and -2. So -1 minus a -2, so we're adding 2. -5 plus 1 is a -4. And -1 plus 2 is 1. Negative 4 squared is 16, and 1 squared is just 1. So we end up with the square root of 17. Now, we could get the decimal, but we don't need it. As long as we end up with square root of 17 for one of the three sides of triangle LPM, then the two triangles are congruent. Now, to do the next side for triangle DVW, that's side VW. Same exact process. Our x values are negative 1, negative 7. So negative 1 minus negative 7 squared plus our y values, negative 2 and negative 4. So negative 2 minus negative 4. Negative 1 plus 7 is 6. And negative 2 plus 4 is 2. Six squared is 36. And 2 squared is 4. And we end up getting the square root of 40. And just like with the square root of 17, we're going to leave it there. If we get another square root of 40 later, then we're good. Last side for triangle DVW is side WD. So going back to the beginning. So our x value is negative 7, negative 5. Negative 7 minus negative 5 squared. And negative 4 minus negative 1. Negative 7 plus 5 is 2. Negative 2, sorry. And negative 4 plus 1 is a negative 3. Negative 2 squared is just 4. And negative 3 squared is just 9. So we end up with the square root of 13 here. So now if we get the exact same 3 square roots for the other triangle, LPM, then we do have 2 congruent triangles. So got to do all this all over again, this time with LP. Use a different color for this one. LP. X values for L and P are 1 and 2. So 1 minus 2. And the Y values are negative 5 and negative 1. So negative 5 minus negative 1. One minus 2 is negative 1. And negative 5 plus 1 is negative 4. Negative 1 squared is just 1. Negative 4 squared is just 16. And we do end up getting our square root of 17 out. So far, we are good to go. Now you got to keep going. To PM. Here, our x values are 2 and 4. So 2 minus 4. And our y values are negative 1, negative 7. So negative 1 minus negative 7. So 2 minus 4, negative 2, plus negative 1 plus 7, 6. Negative 2 squared is 4, and 6 squared is 36. So we do get our square root of 40. looking like we're going to be congruent here. We are getting the exact same order. So as long as the last side ML does come out to be the square root of 13, then we're going to be good. So we do square root. Our x values 4 and 1. Our y values -7 and -5. Four minus 1 is just 3. And -7 plus 5 is -2. Three squared is 9. -2 squared is 4. We've got 9 plus 4. That does get us our square root of 13. So we do have congruent triangles. And these are congruent by side, side, side. Long problem. The rest aren't that bad. So, side angle, side congruence. If two sides and the included angle of one triangle are congruent to two sides and the included angle of a second triangle, then the triangles are congruent. So here is our pair of triangles based on a moth. We're given some information about these triangles, namely that EI is congruent to FH, so those are the two diagonals. We're given that G is the midpoint of both EI and FH, so that means that EI is being split in half exactly, and FH is being split in half exactly, which means all of those are congruent. So we have our two pairs of sides that are congruent. We need an angle that's congruent in between. The only option here is the one right in the middle. And of course those are congruent because they are vertical angles. So let's list these out and the reasoning. So FG is congruent to GH. And the reason is that G is the midpoint of FH. So there's our side. That's a little bit too big. That's all right. And then our next one here, the angle, side, angle, side, right? So our angle here is, we're going to name these as FGE, being congruent to angle HGI. It really doesn't matter which way you name it since the sides are all congruent. HGI is just fine. That's because they are vertical angles. So there's our angle, part of side, angle, side. And then the last side part, same reasoning as the first side, but now we're looking at EG being congruent to GI. But the reason again is the exact same reason. G is the midpoint of EI. So there's our third side, and now we just need to have a congruent statement. So we have side, angle, side, congruence. So triangle FGE is congruent to triangle HGI. It's the risk of making videos at school. You never know when the announcements are going to happen. But there's our congruent statement here. So angle, side, angle congruence just says if two angles in the included side, it's just the reverse of what we just looked at, and the included side of one triangle are congruent to two angles in the included side of another triangle, then the triangles are congruent. So here we're given a couple triangles, and we're also given some information that L is the midpoint of WE, and that WR is parallel to ED. So L is the midpoint of WE, means that these two are congruent. Again, we have vertical angles here. Now we're looking for angle, side, angle. We have to go in order, right? The side has to be in between. So that means that we need W to be congruent to E. And the reason those are congruent is because of that parallel part. So we can mark these two as parallel with little arrows. And because we know they're parallel, W and E are alternate interior angles, so that makes them congruent. Only because they are parallel. If we did not know that WR and ED are parallel, then we could not say that those two angles are congruent. They would still be alternate interior, but they would not necessarily be congruent. So, let's list them out, just like we did before. So angle W is congruent to angle E. It's because they are alternate interior angles. Where WL is congruent to LE because L is the midpoint. Of WE. So we have our angle, we have a side, now we need one more angle, and that is the vertical angles there in the middle. So we just need to name them RLW, congruent to D, angle DLE. And again, it's because they are vertical angles. So we do have angle, side, angle congruence. So that means that triangle WLR is congruent to triangle ELD. Angle, side congruence, the last one we're going to look at today. If two angles in the non-included side of one triangle are congruent to the corresponding two angles and a side of a second triangle, then the two triangles are congruent. So here we have two triangles overlapping each other. We're given some information. We're given an angle and a side. So we need one more angle. And it can't be the included angle between, it can't make that side that we do know is congruent be the included side. That's what we can't have included. So, if you notice here, angle NKL is up on the top to the right. Angle NJM is up to the top on the left. KL is the top side for the triangle on the right. JM is the top side to the triangle on the left. So we have angle side, and we need the angle to the left, or to the, I guess, a counterclockwise rotation for triangle JNM. So that means it's got to be this angle here. And if you notice, it's also being used by this triangle here. So angle N is congruent to angle N because it's the same angle, right? So that's our first angle. So angle N is congruent to angle N. Obviously the reason there is the what's called the reflexive property. Helps if I spell reflexive, right? Reflexive property just says you have the same thing congruent to itself. So that's our first angle. The other angle is NKL and NJM. They're given to us. Angle NKL congruent to angle NJM. The reason for that is given. And then for our side, same thing. KL congruent to JM. And again, the reason is because it was given. So we do have angle side congruence. So triangle JNM is congruent to triangle KNL. So here we have this envelope. So Barbara designs a paper template for a certain envelope. She designs the top and bottom flaps to be isosceles triangles that have congruent bases and base angles. If EV is 8 centimeters and the height of the isosceles triangle is 3, we need to find PO. So you're given that these two are 8 because we know that they're congruent. And the height of the isosceles means that this side here is 3. Remember, we're trying to find PO down there. So since PL is 8, and we know that the height, it's an isosceles triangle, so the height is going to split it in half. That means that this side is 4. So now we can use Pythagorean theorem. So 4 squared plus 3 squared is equal to PO squared. So PO squared is equal to 4 squared is 16, 3 squared is 9. Add those up, we get 25. Then we need to square root both sides to get rid of the square. So that means that PO is equal to 5 centimeters. Alright, so there's a little review of all 4 types that we've looked at. Here's your exit ticket.